Let's see maximum distortion energy theory for ductile materials. This is also called von Mises theory. This theory states that maximum distortion energy at a point in material, when it exceeds distortion energy in uniaxial test, the material fails. So this is the formula of distortion energy. This is in form of principal stresses: sigma 1, sigma 2, sigma 3, and it is given by this formula, distortion energy. Now we know the key observation in the failure of ductile material from the experiments is that the mechanism of yielding is due to shear deformation. And this distortion energy and this formula is derived from the deviatric stresses of component. Deviatric stresses components, which is responsible for shear or distortion. So this is a distortion energy formula for triaxial state of stress. And for a distortion energy in uniaxial test, okay, we can simply put sigma 2 and sigma 3 equal to 0. We get a distortion energy for uniaxial test as 1 plus nu Poisson's ratio divided by 3e sigma y square. Sigma y is yield strength of the material. So this is the left hand side term and right hand side term. By expanding or simplifying, we get something like this. Okay, this is the von Mises criterion. Whereas this left hand side, okay, it is also called von Mises stress, or we can say it is the equivalent stress of triaxial state of stress. Okay, so when this equivalent stress or von Mises stress, if it is more than yield strength of the material starts yielding. Let's see von Mises theory, the graphical presentation. Okay, for 2D case, so we are just substituting in this sigma 3 equal to 0. We get uh, von Mises yield surface in 2D as sigma 1 square minus sigma 1 sigma 2 plus sigma 2 square equal to sigma y square. So this is a basically elliptical equation, and this yellow is von Mises yield surface. Okay. And when we superimpose von Mises and Tresca yield criterion, we get something like this. Here we can observe that von Mises, sorry, not von Mises, but the Tresca stress, okay, Tresca equivalent of stress is more conservative. Okay. If you see, if the point lies somewhere here, okay, or in this region, as per Tresca, this point fails. Okay? It is considered as a failure. But as per von Mises theory, this point is still in no safe region. Okay? It is not failing. So we can say the Tresca is more conservative. And the maximum difference between von Mises and Tresca yield, Tresca stress is 15.5 percentage. Okay, this much. This looks like the maximum, and this one is 15.5 percentage. So we can say like Tresca is more conservative than von Mises theory or criterion. Okay, the reason is also that in von Mises we have sigma 2, whereas in Tresca, okay, uh, if we see Tresca in 2D here, okay, it doesn't have sigma 3 component of sigma 3. Okay, so Tresca actually ignores the effect of, okay, one of the principal stress. Okay, and that is the reason it is more conservative. And apart from that, though one von Mises stress is not conservative, it is most preferred or more popular criterion for ductile materials. The reason is that it agrees better with experimental data. Okay? So it is in more agreement than a Tresca criteria.